Good afternoon. Thank you all for joining us. My name is Nora Sherman. I'm the Director of Communications for the CUNY Building Performance Lab. Thanks for joining us. This is actually the first in a series of webinars that we're going to be doing on our training offerings over the summer. These training offerings will be held in the fall, but these are just 1-hour sessions for you to get an overview of what kind of training will be available to you. So we have two people who will be speaking today. We have Paul Reale. He's our Senior Technology Project Manager. He is very familiar with building retuning, which is a method for unlocking the hidden energy savings that exists in your building automation systems. So that's the class that we're going to be talking about today. After Paul speaks about the content, Daniela Leifer, who is our Manager of Training Programs, is going to talk about the NYSERDA discount that we have available through the end of this year, which allows us to offer building retuning at 60% off. So, take it away, Paul.
Okay.
Oh, actually, one more thing. If you have any questions, I think the best thing to do would be to just enter your message into the chat box on the right side of your screen. Otherwise, we can just open it up to questions at the end, and you can use either your phone or you can speak into your computer's speaker. Thank you.
Hi, good afternoon, everyone. This is Paul Reale, and thank you, Nora, for that. I appreciate it. I am the Senior Technology Project Manager here at the Building Performance Lab. I'm also a teacher of the Building Retuning class, and I have taught a number of classes that have to do with energy efficiency, with building sustainability, building operations, and I have to say that building retuning really strikes me as a very powerful technique for reducing energy consumption for little or no cost, usually, in fact, no cost. So I'm going to spend about 30 minutes going through a kind of a sampler of the material that is in the class, give you an overview of what the content is. The actual class is, I believe, 5 sessions at 3 hours each, so it's a total of a 15-hour class. It also includes a project. So we're just going to have a little appetizer here just to give you a sense of whether this might be valuable to you. And of course, if there are any questions before we get started, I'd be happy to take any. Let's see if I can click on something. You can hit the chat function, use the chat function, or I will try to open this up audio-wise. Can you do that?
Let's do the chat function for now. We'll do audio.
All right, let's try chat for now. So please just type into the chat bar on the right side if you have any questions before we get started. How do I go to the next page? There we go. Okay, I don't see any questions just yet, so feel free to jump in at any time. So this is the intro to retuning, intro to building retuning, and the question is, of course, right at the onset is, what is it? And this is a process that will help to identify any kind of operational problems that you have in your building that could lead to energy waste. This is not intended to be a commissioning or a retro commissioning type service. This is not intended to be energy auditing where we're looking for, more kind of capital intensive projects. Rather, this is primarily implemented through your building's automation system. And really the only cost here should be the labor required to perform the process. There may be a few low-cost repairs. You may find that when you, in fact, learn about building retuning and do a little digging about what, in fact, your building automation system is capable of doing and what it's connected to, you may determine that there are a number of sensors that, may need to be calibrated or repaired, those kinds of things, in order for you to leverage this technique. But obviously, those would be low-cost type repairs. Building retuning was developed by, originally funded by the state of Washington, and then it went beyond that with the Pacific Northwest National Laboratory with funding from the United States Department of Energy. So this was a federally funded and developed technique from a national laboratory, and the primary idea here was to look for organizations with a lot of building stock that would be interested in getting training on the retuning process. So this has been out there for a few years right now, and actually there have been some real good winning stories about this, and I'll touch upon one or two of them in the minutes to come. But the purpose of the technique is really to improve the building's energy efficiency. Obviously, reduce the energy consumption. That's obviously not by sacrificing comfort type issues and the like, rather just to help the building operate in a more energy efficient way. We could also identify opportunities to further increase the energy efficiency, the building's energy efficiency. There are 9 techniques that were developed, 9 building retuning measures that were developed by the Pacific Northwest National Laboratory, or PNNL. We run through all of those in the class. We would also identify problems that may require physical repair. Typically, as I say, those are very low-cost type of repairs having to do with sensor calibration or maybe even simple things like you may notice when you're going through the building retuning measures or through the process and your walk down, that you have things like broken linkages in your dampers and things like that, which can in fact lead to vast energy losses. So it really does a great job in catching the energy saving opportunities, real big energy saving opportunities in operations. And I will tell you that I have actually seen a number of people that have taken this class, really good building operators, really understand their technology, really understand their buildings, actually find some tremendously low fruit that has paid off. We've really hit pay dirt with some of these things. So I really do believe in the technique. So the steps, the main steps in retuning is obviously starting with some initial building information. There's a pre-retune process which gets into making sure that your building automation system is set up properly with the sensors, and so you can understand what sensors are available, and also setting up your trend logs to look at some set of parameters, a prescribed set of parameters prescribed by the building retuning measures, conducting your building walk down and looking for any physical issues that we can kind of help you keep an eye out for. Do the retuning itself, which is to then looking at the actual trend logs, diagnosing any issues that you may have in your building. It may have to do with any number of issues, which we'll cover some of the areas, and then take any corrective actions that you may have identified. Gathering data afterwards is always a good idea, so that enables you to perform a savings analysis. Obviously, that's not required. But it is preferred, because if in fact you do justify the amount of savings that you've realized, it could be any number of, sometimes the savings are 10%, 20% overall building energy savings from things that, again, can easily be overlooked. Once you identify those things, those are fantastic justification for either more budget for other related measures, or in fact maybe even other projects that you might want to take on. So that's always good for reporting back to the managers and those that hold the purse strings. So here is a PNNL case study, Pacific Northwest National Laboratory case study. This is the Sam Nunn Federal Center in Atlanta, Georgia. It's a 1.8 million square foot facility. It has all electric perimeter reheat, 4 chillers, 3 of them 1,500 tons, 1 of them at 500 tons, variable chilled water flow. The VAV air handlers are paired for each floor, about 100 air handlers in total. As a result of this, I think this is about a 2-year effort. They received the Energy Star rating in the end. The energy was down 15 to 20%. The peak was down on the shoulder months, which obviously led to major cost savings. And highlighted here is also the fact that tenant complaints dropped 35%. So this is, really, there's a lot that in fact can be gleaned from these techniques that are taught in this class. These are the major areas of focus. They essentially it's essentially the list of the BRT measures. We talk about occupancy scheduling. There's a tremendous low fruit with occupancy scheduling. Looking at discharge air temperature control. And so not sure if everyone that's on the call is familiar with all the terminology. So if you look at the diagram on the bottom right of the slide, it shows your basic air handler. Obviously on the lower portion to the right of the VFD that's driving or controlling the supply fan, that would be your supply air or your discharge air. Coming in from the lower left-hand side would be your outside air. coming down from the top would be your return air that would mix with your outside air to give you, where that word filter is, to give you your mixed air. And then, of course, you've got on the top left a spill damper. That would, if you have any incoming air, you've got a balance. So we have a building retuning measure having to do with discharge air temperature control, another one having to do with discharge air static pressure control, and one or the other may be favorable or useful to you depending upon your equipment setup, on whether or not you have VFDs on your supply fans and the like. Also, air handling unit heating and cooling. We talked about outside air, fresh air makeup, and looking at the level of ventilation that you're providing. That's very key. In fact, I'm working on a job right now where, in fact, we discovered that the ventilation was significantly greater than it needed to be. And by repairing that problem and including a new technology in energy recovery ventilation, now this is actually a capital project, but we're going to be able to reduce the energy consumption in that building overall by 30%, a 30% reduction in energy consumption. So again, dramatic savings. Economizer operation, making sure that you're familiar with the best way to use that. Many of you are, I'm sure are aware of how to economize, but having a keen awareness of when you can and when you shouldn't economize is important, and leveraging that whenever you can makes a big difference and helps to minimize energy for your chillers especially. Zone conditioning, central plant for both heating and cooling, and looking at meter profiles. All these are very useful techniques, again, developed by the Pacific Northwest National Lab. And the overall process is essentially to use data that is gathered by your BAS, your building automation system, to identify those opportunities. But of course, not only the data, but the measures themselves. Gather the data, plot it graphically using, creating trend charts, and then the interpretation is the key. Determining what the appropriate level of, levels of energy consumption are, or shall I say, looking for keys in the parameters that you're tracking that would help you to diagnose any energy, wasteful energy practices that are actually going on in your system. Again, it's all about comfort, right? That's the top priority, and after that, we like to do it affordably. And so, we might, in fact, have comfortable occupants, but in fact, what we might also be doing is not heating or cooling in a way that is very energy efficient. So that's what this is all about, is trying to diagnose those issues where there are opportunities for energy savings, and then prescribing what changes, in fact, could be made in order to realize those savings. Okay. Again, if you have any questions, feel free to type any questions in the chat window on the right side. I would like to spend a few minutes now just going through a smattering of some of the kinds of things that we do in the building retuning class. So here in this first example, we look at occupancy scheduling. So take a look at this chart, because this is where the fun really begins. Along the x-axis, you see time. And you can see that this is, in fact, a 24-hour period of time. On the left-hand y-axis, we see temperature in degrees Fahrenheit. And on the right axis, the right vertical axis, we see the outside air damper position in terms of the percentage that it is open. If you look at the outdoor air temperature, we're plotting two parameters here, outdoor air temperature and outdoor air damper position signal. The outdoor air temperature, or the OAT, varies, as you can see, generally between 30 and 40 degrees during this 24-hour period. So obviously it's cold out, and we don't want it to be that cold inside. We would rather not bring a lot of that air in when we don't have to. Of course, we need to bring fresh air in order to ventilate. People need to breathe 15 cubic feet per minute per person, typically, or something comparable. Maybe it's just a number of air changes per hour, or there are different ways of ventilating properly. But what you can see here is that the outdoor air damper position signal is showing that it's open about 15% for the entire 24-hour period. Now, if this is a commercial building and there are no people in the building at night, it would be wise to close your outdoor air dampers at night. So that's an opportunity that we identify here. Operating at 15% open may actually be appropriate for the amount of ventilation that's typical for a minimum setting for ventilation. So it's probably good during operating hours, but then again, during off hours or unoccupied hours, we would want to drop that down. So we say that this is bad operation, the damper's at minimum position, that letting in cold air during unoccupied hours. Again, just a simple example of occupancy scheduling, looking at a trend chart. Here's another one that looks at the same thing. It's the exact same temperature profile, the exact same setup for the exact same building. But in this case, not only are we looking at the outdoor air damper position signal like we were before, but the dark line actually also looks at the supply fan status. So it tells us if the supply fan is on. In this case, we see that it's the same 24-hour period, the same temperatures outside, and the outdoor air damper position signal shows that it's open at minimum position for most of the day during the occupied hours. In fact, it's even closed during the warm-up period, during the first hour of warm-up when people have not yet arrived. So this is an example of good operation. The damper remains closed when the building is not occupied. It remains closed during building warm-up. So this is obviously a good operation. So you save all that energy that you would have otherwise thrown away if, in fact, you have the outdoor air damper position open. And by the way, if the fan were on at those unoccupied hours, then you'd really be losing a lot of energy. Okay, going on to another example. Let's say you've got dampers in your VAVs, and you want to track the damper positions. In this case, you can see that we're plotting 10 dampers. They all seem to be open during occupied hours between 50 and 75%. That's considered good operation. And you can also see that this is going on during what is presumably occupied hours. Now, this seems to be it's probably possible in this case that you could narrow down the hours of operation. It looks like the dampers are opening at 4 in the morning. I don't know if the supply fans are on at this point, but there doesn't seem to be any need for the dampers to be open at that early hour unless you've got an early shift going on in this building. So we've got the dampers essentially closed for the most part, or closed way down during the unoccupied hours, and then open at an appropriate level 50 to 75% during occupied hours. That's an example of good operation. We like the damper, the VAV dampers to be around that area. That means that they're, it's a good area for them to be in terms of, overall control of the system. Here's another example of that same scenario. Only in this case, we see that the dampers are yawning wide open, and you can see that there's even one damper. It looks like damper number 3 is open all into the night on that first night. When they're open this wide, it means that they're asking for more air. They need more air. They are, as we say, starved. And so in this case, if you've got the ability to build the trend chart for these kinds of zone damper positions, you can see that, you've got some real issues here and that your system needs to obviously have some more air. Let's go on to this next example. Similar situation, except instead of the damper, the VAVs being starved, you can see they're all shut almost all the way down during occupied hours. In a situation like this, it seems pretty obvious that the duct static pressure is probably way too high. They're getting way too much air, and so this is an opportunity to back off on the duct static pressure. I call this the dampers or the VAVs actually being stuffed. They're not starved, they're stuffed. And in a situation like this, obviously, you've got an opportunity. If you've got a VFD on the motor that drives the fan and your air handler, you can use it. You can back off. And, knowing that, the speed of the fan is proportional to the cube of the power that it consumes in the motor, if you can cut that fan speed by half, you've cut the power consumption by a factor of 8. So tremendous savings opportunities here. I realize that the chiller and the compressor in the chiller, if you've got an electric chiller, is where, that's the big energy hog in your cooling system, in your cooling plant. But these fans, don't, they consume a lot of energy as well. And so there's some real opportunity here. All right, let's look at another example, looking at the possibility for economizing with your air handler. Taking a look at this, this train chart, you can see that we have basically a 2-day period here. You can see from the pink line, that's the outdoor air damper that opens and closes. It looks like it's opening and closing during operating hours, open during operating hours and closed otherwise. It also looks like your outdoor air temperature in blue looks like it's getting pretty warm during the day. It's in the low 80s, mid 80s during the day. And your return air temperature, it looks about right. It's about, what, low 70s to mid 70s. The question is there an opportunity here to economize, to use free air cooling? If you look carefully, the answer is yes. The answer is yes, not all day long, but you can see that early in the day, that the outdoor air temperature is significantly lower than the return air temperature. Well, when that's true, you can go ahead and just use the outdoor air temperature. You'd be better off dumping the return air to the outdoors, bringing in fresh air from the outdoors, and it may still require some cooling, but it won't require as much as that return air. It's cooler. So that's an opportunity to economize. So during those periods, for example, in the first day, for the first couple of hours, where the outdoor air temperature is below the return air temperature. And you might want to put a margin in there based on relative humidity if it's humid out, but still. You could have the outdoor air damper position fully open during that period, but then when the outdoor air temperature exceeds the return air temperature, you would want to close down your damper to minimum position and only bring in enough outdoor air temperature as is needed for ventilation. So that would be a much better sequence of operations. So again, by using building retuning, we tell you which parameters you need to be tracking and trending in order to find out, you know, where these opportunities are. And within the measures, in fact, in the economizer questionnaire that's part of the building retuning measure, I think it gets into 11 or 12 different questions, different things to look for. Very useful material. So that's bad operation. We can see that there, that the outdoor air damper is way too far open, and we're having to cool down that outdoor air any more than the return air. Now here's a sample. Here's another economizer example where once again I've got a 2-day period, and you can see that the discharge air temperature set point, that's the air coming out of my air handler, is set for constant 55 all day and all night. The outdoor air temperature varies from 40 to 50 degrees Fahrenheit, depending on the time of day. And you can see that the outdoor air damper position signal is open during occupied hours. Well, it's good that the outdoor air damper position is open. The outdoor air damper is open during occupied hours. But it looks like we've also got the cooling coil valve. You see the light blue down in the lower portion. The cooling coil valve is open about 20% of the time during occupied hours. So you can see that there's an opportunity here for economizing, and yet we're using our cooling coil valves. Sure would be good to use some economizing here. So obviously we have a good situation here for full economizing because the outdoor air temperature is lower than the discharge air temperature set point. So we really could be economizing here all the time and reducing the amount of chilled water that we're sending into our cooling coils. Another example, similar situation. Once again, we've got our dampers open during the day, the outdoor air dampers. They're open 75% on the first day and 70% on the second day. The discharge air temperature set point is once again at 55 degrees. Outdoor air temperature varies from 40 to 50. Good opportunity for economizing all day long, and that's what we're doing. We've got those dampers open. The fans, it doesn't show that they're on here, but obviously they are, because the cooling coil valve signal shows that it's absolutely closed. It rides the x-axis, if you will, or the time axis way down at the bottom at 0. So here we're actually economizing fully, and there's no need for cooling coil valves to be open, and therefore we're not using the energy that gets sucked up by the chiller. So some real energy savings here. Okay, Another couple of examples here on the left-hand side. Once again, this is a 24-hour period, and you can see I want you to keep in mind now, the outdoor air temperature, we know what that is. We've got return air is in the orange line running along the top. And then we've got the outdoor air mixing with that return air to make the mixed air. You can see the mixed air temperature on the left-hand side is following the outdoor air temperature very closely. And what that tells you is that most of your mixed air is in fact outdoor air. You're throwing away most of your return air. So in a situation like this, you can see if you've got a discharge air temperature that's way up in the 60s or 65 degrees, you're having to reheat that air dramatically. You would be far better off bringing in a lot more of that return air instead of the outdoor air to create your mixed air so you don't have to heat it as much. Once again, opportunity for energy savings because we're having to heat that air quite a bit. On the right-hand side, it's a much better scenario because now we're saying that our mixed air temperature is much closer to our return air temperature because this is not really good conditions for economizing, and the reason it's not good is because it's too cold. We don't really want to economize typically when it's in the 20s outside. A couple more examples. Here's another one where we look at the chilled water loop in your chilled water plant. So on the left-hand side, you can see the outdoor air temperature varies starts out at 60, heads all the way up to 80, and then drops down into the 40s at one point. Our chilled water supply and our chilled water return temperatures are plotted all day long for this entire 1 week period. And you can see that the difference, or the delta T, the change in temperature in the chilled water supply versus the chilled water return temperature is very low. It's only a few degrees. We don't like that. Obviously, in order to get good operation out of your chiller, which is a very expensive piece of equipment to run, you would want to have a much larger delta T. Let's make use of all that chilling that we've done. On the right-hand side, you can see that obviously it's a much better delta T, closer to 10 degrees. Okay. Well, that's it. I just wanted to give you a kind of a smattering of the kinds of things that we talk about in building retuning. I want you to, did you want to explain the discount again?
Let's open up to questions.
Yes. So let's open it up to questions. I do want to give you an opportunity to ask questions, and then Daniela Leifer is going to ask questions, or give you an opportunity to tell you about the offerings and when it'll be available and things like that. So we've unmuted, and so you can speak right into your computer, or if you're on the telephone, speak into your telephone if you have any questions at all. Any questions at all? Okay. Was that? Is anyone there? Was that useful? Can anybody comment on the content that they just saw? Does this actually seem like it might be useful to you?
I see that we got a couple of questions via chat.
Oh, there we go.
For sending those.
Oh, there we go. Okay.
Will this preview be available online? We are actually recording this session, so we may end up making this available online, yes.
Okay.
Next was a comment. Very good summary. Thank you very much for that.
Thank you, Donna, for that. All right.
Okay, so if nobody has additional questions sort of on the content side of things, then I'll go ahead and just talk a few minutes about the logistical side of our training program, upcoming trainings, etc. So let's see if I can get these slides to change.
There you go.
Oops. Okay. So the first part, of course, that I wanted to talk to you about is that if you may not already be aware of this, the CUNY Building Performance Lab has training support funding through NYSERDA. This is a program that we have partnered with NYSERDA in the past to run trainings under similar kind of tuition discount programs. So it comes down the pipeline from NYSERDA every couple of years. So that is a big part of the reason why we are doing heavy promotion of our training programs, because we have this nice service support for them. So throughout the end of 2015, the tuition support program is available. And under this iteration of the NYSERDA program, tuition is discounted by 60%. So participants are responsible for 40% of the cost of the normal price, what you would normally pay. And it will be different for each of our training classes, of course. For the building retuning training, the regular price, unsubsidized, would be $800, and the discounted price is $320. So NYSERDA subsidizes the remaining cost above the $320. Eligibility is for the tuition discount is usually available for most people. You have to have either a home or a workplace address within New York State SBC utility territory. SBC stands for Systems Benefit Charge. It's a charge on your utility bill, meaning that you have contributed to NYSERDA's funding, essentially, through your utility payments, your monthly utility payments. So, this program is funded by the public, and it's for the public. So that tuition discount is usually quite widely available. The only major New York State utility that is not part of the New York State SBC program is Long Island PSEG, which was formerly LIPA. Out-of-state participants, if you live out of state, say New Jersey, but you work in New York State, that you're fine. Eligibility is covered by your workplace. And for anybody out there who may work as a NYSERDA implementation partner under the EEPS program, even if you're not located in New York State, NYSERDA EEPS program participants are also eligible. So eligibility is pretty, it's usually pretty open. And then finally, non-eligible participants can take the course. You'd have to take it at the regular price. As far as scheduling, I just wanted to touch on that the Building Performance Lab, we run trainings both on what we call an open enrollment basis and also closed enrollment basis. The open enrollment classes are those that are open to the public. We schedule those typically on weekday evenings, once or twice a week. They take place at our training location, the CUNY School of Professional Studies, which is located on 31st Street in Midtown Manhattan. The next building retuning training, as well as our other classes, will be scheduled in the fall. Typically, for the building retuning training, since it's somewhat short, 15 hours spread over 5 to 6 weeks, we usually would start it. We're looking to start the next one probably late September, early October. We also run closed classes on behalf of institutional clients. These are arranged with the client exclusively for your staff or members. So that means that we're contracting with the client to run the training for you. So scheduling, location, etc., are arranged according to whatever the client's needs are. Trainings can take place at the client site on the client schedule. This just requires a minimum class size of 12 people. And for any additional details, that's arranged through me. And finally, oops, one more slide that I can't seem to get to. Okay. And finally, I just wanted to touch on this as well. Building retuning has been approved for a number of continuing education credits for various certifications and licensing. We'll provide 15 PDHs for professional engineers through the Practicing Institute of Engineers. For this one, the attendance is a bit strict. Full attendance is required. You can't miss a class, essentially. You'd have to attend all five classes in order to get the credit. For some of the other programs, attendance is not full attendance isn't required. You would get 1 hour per classroom hour, essentially. But it is eligible for 15 lead CEs, 15 maintenance points towards the building operator certification, and 15 CPD, continuing professional development credits, toward various BOMI certificates and designations. With that, that's the details that I wanted to cover, so I'm going to open it back up to questions. I had one more question come in through chat, a PDF of the slides. Yeah, I think we can arrange that. That would be fine. It's the slides that we used here kind of presents a small sampling of the the larger class. So they would help provide a good good examples if you're looking to especially share this information with others or anything like that. I turned the mic back on, so if anybody does have questions, you can just jump in. Otherwise, I will send a PDF of the slides to everybody who attended, and I can also let you know if we, or when we get these posted, when we get the recording of this webinar posted onto our website. I can certainly let everybody know. Yeah.
So yeah, this is Paul again, Paul Reale. So yeah, again, happy to answer questions not only about all the things that Daniela was just speaking of in terms of the availability of the course, the 60% discount and so on, but also any questions about the technology. I do want to make it clear that part of the class includes a project. So it would be wise that you, this class is really suited for people that do have access to building automation systems. So feel free to ask any technical questions, prerequisite questions, registration questions. I'll just be silent for a moment and give you a chance to jump in. The microphone is open.
Another question here is, were all of the graphs taken directly from the BAS?
I think, no, actually building automation systems, those graphs that you saw were constructed or pulled from the building retuning measures. Often it's the case that building automation systems can trend like that. Often it's the case that they cannot. And so part of the training includes something called the Energy Charting and Metrics Tool, or ECAM, which was is an Excel-based tool that was developed by the Pacific Northwest National Lab. And it allows you to import data from your building automation system, and it gives you the ability to go ahead and create those trend charts. Very good question. Thank you.
We have actually found in a number of our previous classes that we've run that you'll get a mixed bag. Some of the class participants have BMS systems that can, not only collect the data, but can create graphs. Sometimes they might find that easier to use because they're already a little bit familiar with using the graphing capabilities of the BMS. Whereas other students in the class may need to use this ECAM tool, which is, again, simple. It's just an Excel add-on. Doesn't require even any downloading, I don't think.
And by the way, let me also add that part of what we do here at the Building Performance Laboratory, when we teach the building retuning class, is we have a team of interns that actually do this for a living, that actually do building retuning. And we do, in fact, make them available to you if you're having difficulty creating your trend charts in your building automation system, because they're very familiar with the variety of systems that are available out there. So that's all part of the deal. Any other questions?
Well, I think we're just about coming to a close here. If people do have other additional questions, please feel free to reach out to either myself or to Paul. I intended to put contact information up here, so my apologies for not doing that, but I'll follow up in an email with our contact information, so you can reach out if need be. So thank you everybody for participating. Appreciate your time, and hope you learned a lot.
Okay, thanks everyone. Take care. Have a great day.
I'd also like to make one more plug, which is that we have, as Nora mentioned at the beginning, a series of webinars for our other training classes as well. So stay tuned. I've been announcing those via email, hoping to try not to clog people's email inboxes up too much, but you'll get a couple of more announcements about our other webinars coming up over the next several weeks. So thanks again.
Thank you. Bye.